Alright, hello guys. We want to in this video show how to draw a network diagram for project management, and of course we know is a project management technique that helps us to do proper scheduling and gets us to allocate our resources appropriately. So this is a situation where we have um, the jobs. We have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I get that correctly? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 jobs, which one can also call tasks, then and the immediate predecessors, and the time for completion of each of them, and we are required to find out after drawing the network diagram, showing the precedent relationship, that exist amongst the activities um, involved in completion of the project. We also asked to also be required to find out the project minimum completion time. That's the minimum time that the project will be completed. Um, so we are going to first of all demonstrate how to draw the network, and then now all other computations will follow. Then of course we know we have two ways of determining this. We have what we call the activity on arrow and then activity on node. So for us in this video, we're going to adopt activity on arrow method. But first of all, let's show how to draw the network diagram. So um, as mentioned earlier, a network diagram shows the relationship amongst the activities. Which one comes first? Which one precedes? Which one succeeds? Do we have possibilities of carrying out two activities simultaneously and every other thing? We're going to see how that will play out now. So for the first thing we're going to do is to start from the base. What this means is activity A is the base activity. That's the first activity that will be carried out in an attempt to complete the project. And it starts from point 0. That's why we have this hyphen this hyphen here to show that it's starting from the base. It's the beginning point, the starting point of a project. Then after A, B, and B is taken after A. Then C comes after B. D is also coming after B. Then activity E has to start after the completion of C. Then activity F comes after D. Activity G also comes after C. H comes after the completion of activity E and F. Then activity I comes after the completion of G and H. So what do? We start from the base. Then the diagram will now continue progressively towards the right. So let's use this node, which is said to be a milestone. A node represented by this cycle is just a milestone that represents either the beginning of a particular activity or the ending of a particular activity. So by definition, we call this thing a node. Yeah. And the activity itself is called is represented by an arrow. This is an activity. Represent the activities, as we have 9 of them here, by an arrow. So we're going to use this and this, a node and activity, to show the relationship that exists amongst these activities, to show how they interrelate. So the first will be the base activity, which is A, starting from nothing, if you like. So this is our A, starting from nothing. This is the first node, and this is our A, taking off from nothing. It's also important to mention that the length of the activity is size. That's the length of the arrow. Has nothing much to do, has nothing to do with the activity time. That is to say that it's only about the relationship. We can't use a very short arrow to represent 20 and use a long one to represent 10 or even 5. So it depends on the nature of the interrelationship among the activities. So now, having now said this, the first is activity A coming out from the base, which is conventionally we label it A, and we bring in the time of its completion, which is 5, and then close it. Why do we need to enclose it? Sometimes the activity labels may come in numbers as well. Assuming this is A is 1 and this is 5. So we do enclose the activity time in brackets to avoid confusion by convention, of course. So it's just for you to be guided, because if you have 5 and 6 here, for instance, one may be easily confused as to which one is the activity time or which one is the activity number. So this is A, and the activity time is 5, maybe in days, 5 days, which means it takes 5 days to complete activity A. Then the next one is B. Activity B comes after A. So at the completion of activity A comes B. This signifies the end of activity A, and B will take off. So have B and the time for completion of activity B is 7. Then activity C comes after B. Activity C comes after B. Right? So the next will be activity D, also comes after B, which means this is the end of B. Activity D can take off from here. So we have D here. And the completion, this is activity C. The time completion of activity C is 2. Then the completion of activity D, time for completion of activity D is 3. Now the next will be activity E, which is coming out after the completion of C. So this is the end of my C. Then activity E is activity E, and it will take 1 day for completion. Then activity F comes after completion of D. So this is the end of my D. Activity F. This is activity F, and it will take 2 days to be completed. Then activity G comes after the completion of C. So this is the end of my C, which is activity G here, and the completion of this is 1. It will take 1 day to be completed. This activity G. Then the next will be activity H, which is coming after the completion of activity E and F. So E and F must have ended before activity H can take off. So which means this is my E, this is my F. So we're going to find a way to bring together activity E and F. So that we extend this down to here, or we clean this and bring it close to here so that two of them will be together. That will signal. Now this is activity F. Activity F. And the completion is 2 days. So this is the end of two of them. H, E and F must end before H will start. So this is the end of E and F. So this is now H. Okay. This is now H. And H will take 3 days. So H will take 3 days. This is the end of my H. Okay, and activity I will come at the end of G, activity G and activity H, which means that activity G and H must come together before I will now take place. So we can extend this. This is activity G. This is the end of activity G and H that will now precede the activity I. So this is now activity I. This is activity I. And the completion time is 10. So this is the end of the diagram. That will be the end of the project. I can decide to bring it down. It doesn't change anything. It's just about, to show where the project ends. Now, this is the precedence relationship that exists, amongst the variables. So the next thing will be to look at the second question, which is the diagram activity involved in project and indicate the critical path. What is the project minimum completion time? So we are going to answer this, and in answering this, we'll answer this too. We'll indicate the critical path. So what happens there is very simple. First, this is the network diagram. Now, the next is to determine the project completion time. Very simple. So what we're going to do is to do what we call the forward and the backward pass in order to determine the project completion time. So in doing that, we will be looking at the earliest finish time of activities, the earliest time an activity can be completed, and after which we are going to determine that for all the activities. Then again, we'll now determine the latest start time. That's the latest time for the activities for all of them. And the rule says when the earliest start time and the latest start time are equal, and the earliest finish time and the latest finish time are equal, that activity is considered critical. So what we're going to do now is to determine activities that are critical by computing the forward pass, backward pass that will also throw up what the minimum completion time will be. So firstly, we're going to do the backward pass. The backward pass to determine the earliest finish time for all the activities. So the formula for computing the earliest finish time for activities is very simple, and it is that the earliest finish time is earliest start time minus the time of the activity plus the time of the activity rather will give us the earliest finish time. So the earliest time the activity can start plus the time that it will take for completion of that activity will give us the earliest finish time. So for backward pass, it is that earliest start time plus time of the activity will give us the earliest finish time. So the earliest finish time for activity A will be, what is the earliest start time? Because activity A is starting from the base, the earliest start time will be 0. So we have that earliest start time for activity A will be 0 plus the activity time for A is 5, which is 5. Will give me 5. As mentioned earlier, this method is called AOA, activity on arrow. AOA method. AOA method. That's activity on arrow method. So we're going to be bringing that here on A. So this is 0 for activity A. The earliest start time for activity A is 0 and the finish time is 5. Of course, the earliest finish time for activity A, a succeeding activity, will be the earliest start time, for activity B that succeeds it. So earliest finish time for a succeeding activity, for a preceding activity rather, will become the earliest start time for a succeeding activity. In this instance, A is preceding B, so the earliest start time for activity, the earliest finish time for activity A will automatically become the earliest start time for activity B. So now activity B, the earliest start time will be 5 plus the finish time, the time for the activity, which is 7. That'll give me 12. So this is now finish time for this becomes the start time for this, which is 5, and the finish time becomes 12. Then we go again, because activity C and activity D will start at the completion of activity B. The finish time for activity B becomes the start time for activity C and of course activity D. So for activity C, the start time will be 12 plus the time of the activity, which is 2, which is 14. So we're going to have 12 and 14. And for activity D, and which has 3 as the completion time, the time of the activity, so we're going to have 12 plus 3, which is 15. So for activity D, 12 plus 3, which is 15. Then again, for activity F, the finish time for activity D, that is preceding activity F, is 15. So we're going to have 15 plus 2, which is the time for the activity, will give us 17. So for activity F, we'll have 15 plus 2, which is 17. Alright, for activity G and activity E that are preceded by activity C, their start time will be the finish time for the activity C preceding them. So for activity G, the start time will be 14. 14 plus 1 will now give me 15. That will be the finish time. So the same thing goes to E, which takes this, which is 14. And the finish time is 14 plus 1, which is also 15. So in that order, you have E. Okay, E. Okay. 14 plus 1, which you have 15. G, you have 14 plus 1, which is also 15. Okay, so the next activity will be activity H here. And as you can see, 2 activities must be completed before H can start. Activity E and activity F must come to an end before H can start. So as it is now, we have 15 as finish time for E and 17 as finish time to F. So what it simply means is that even when activity E ends on the 15th day, H cannot start. So Mr. H must wait for activity F to be finished before it starts. So what will be the the earliest start time for activity H will be when F ends, which is 17. So for when we have 2 activities ending into a node, the one that has the highest finish time will be the start time for the succeeding activity. So we're going to have 17 instead of 15. We have 15, we have 7, so I'm going to take 17. So for activity H, we have 17 plus 3, the completion time we have 20. So for H, we have 17 plus 3, it gives me 20. Okay, same explanation goes to this. We have 2 activities, activity G and activity H, coming into this node, that will now precede activity I, which is the last one. And we have 15 here and we have 20 here. Because 20 is higher than 15, we're going to select 20 to be the beginning of to precede activity I. So when Mr. G finishes on the 15th day, I cannot start. So I must wait for Mr. H to end, its own dealings on the 20th day for it to start. So we're going to choose 20. This is 20 and the completion time is 10. So we have 20 plus 10, we have 30. Okay, so even at this point, we have an idea of what the completion time is. But let's quickly look at the backward part so that we'll be able to determine our critical paths. So we do that by the computation, by computing for our latest start time. It has been said earlier that the activities that are considered critical are those activities that will have the earliest start time and earliest finish time, earliest start time and the latest start time to be equal, earliest finish time and latest finish time to be equal. So our backward pass helps us to compute for our earliest finish time. Then our forward pass helps us to compute for our earliest finish time, but our backward pass helps us to compute for our latest start time. So quickly, we are going to, let's use here to compute for our earliest, for our backward, sorry, this is our forward pass. Ooh, this is our forward pass. So let's use this to compute our backward pass. Sorry for that mix up. So we're going to do a backward pass here, which is latest finish time minus time will give us the latest start time. So this is our latest start time. So we're going to do this quickly, and it's very simple. So we are going to start from here, just like what we did in our forward pass. We're going to start from activity I and walk backwards to our activity A. So for our activity I, which is LSTI, will be LSTI will be LFT, LFT minus T will give us LST. So the LFT for this is 30, because we just impute this latest finish time here, which is 30 minus the latest, minus the time of the activity, which is 10, will give us 20. So we have 30 minus 10 will 20. So for activity I, we have 30 minus 10 give us 20 as our latest start time. So the next will be activity G and activity H. So just like when we were doing our forward pass, the way the two activities ended into this, what we now have here as LST here will now be the latest finish time, the LFT for the two activities that preceded this activity I. So that is why we're going to carry this 20 and bring it here, and this 20 should also come here. So 20 minus 1 will give us 19. 20 minus 3 will give us 17. So LSTH will be 20 minus 3, and that gives us 17. And LSTG will be 20 minus 1, 20 minus 1, and that gives us 19. Now, for these two activities, this 17 should guide these two that ended into it, these two activities that ended into it. Just like when we're moving forward, we're selecting the one that is higher. As this is guiding this, we're going to have 17 here, 17 here. So activity F, LSTF will be 17 minus 2, give me 15. 17 minus 2 here, that is 15. Then 17 minus 1 will give me 16. So for activity E, 17 minus 1 will give me 16. Now we have two LSTs coming back into activity C. So the rule is that when you have two activities coming back into a preceding activity, you choose the smaller LST. So between 19 and 16, we have 16 to be the smaller. So for LST 16, for LST 16 will now be latest finish time for activity C. So between 19 and 16, we are choosing 16. So this will now be 16. Choose the smaller one. Even if we have 3, 4, 5 activities coming into that node, the one with the smallest latest start time will be the one to be the finish time, latest finish time. So 16 minus 2 will give us 2. So 16 minus 2 will give us 14. That is okay, fine. Let's take this one. It's 15 here. 15 minus 3 will give us 12. So for D will be 15 minus 3 will give us 12. Then for C, that we've explained, we'll have 16 minus 2, which is 14. For C, 16 minus 2, we're going to have 14. Then, just like we explained earlier, now that we have two activities, C and D, coming into the activity B, the one that has the higher value, so this is 14. The one that has the smaller value will be chosen. So between 12 and 14, we have 12 as the smaller value. So we're going to choose 12 against 14. So for let's finish time of activity B, we're going to have 12, and B will be 12 minus the activity time, which is 7, minus 7, I'm going to have 5, and 5, the LST here, will now be the LFT here, the latest finish time here, which is 5. 5 minus itself, which is the activity time here, we are going to have 0. So for activity A, we have 5 minus 5. It gives us 0. So having done this, we have essentially, computed the earliest, the forward and the backward pass, and we can see that the minimum project completion time is 30, which is the duration, the longest part. So the next thing will be to compute to demonstrate, to show our critical path. So our critical path is very simple, and we have mentioned that anywhere in this diagram, anywhere in on the activities, this is our earliest start time. That's the earliest time that the activity can start. This is our earliest finish time. This our latest start time, this, and this is our latest finish time. So anywhere or any activity that has the EST equaling LST and EFT equaling LFT is considered critical. And what do we mean by critical? Any extension on that critical part, will lead to the extension in the project completion time. So what we do is to use double strike to demonstrate activities that to indicate activities that lie on the critical path. This is one. This is another one. This is another one. Should I use double strike or ticking the arrow? Ticking the arrow, maybe double the arrow. Then this is another one. This is another one. And this is another one. So the sum of the activity time of all the activities that lie on the critical path will give you the minimum completion time for the project. So the critical path will be A to B to D to F to H to I. So the time for activity A is 5 plus for B is 7, for D is 3, for F is 2, for H is 3, plus for I, which is 10. 5 plus 7, 12, 15, 17, 20, 30, which is 30 days. So the project minimum completion time will be 30 days. Alright, so with this we've been able to answer all the questions. So we have the backward forward pass to help us compute the earliest finish time, and the backward pass to help us compute the latest start time. And we've been able to find out that the critical paths are the activities that lie on the critical path, or their critical activities are A, B, D, F, H, and I. And the minimum completion time is 30. Thank you very much. See you in our next video.